Since the dawn of time, humans, in their search for shelter, have followed the examples provided by nature. In the beginning, they lived in shelters formed by the earth. Later, they learned to take the earth itself, shape and mold it to meet the needs of their developing societies.
Earth architecture? No, never heard of it.
An earth house. An earth house.
Eskimos, they build that stuff out of snow. So that's earth architecture right there.
Flintstones, meet the Flintstones. They're the modern Stone Age family.
Well, essentially primitive cultures at this point.
Up until the Industrial Revolution, a majority of the global population, from Asia to Europe, from the Middle East to the American Southwest, housed themselves in structures made of earth. At present, the number of these earthen dwellings is rapidly diminishing.
I don't know, it's too primitive for me.
During the 20th century, it is believed that more people have inhabited our planet than all the rest of recorded history. With this unprecedented growth came the overwhelming demand for shelter. Earth architecture, which had been associated with the traditional lifeways and proud craftsmanship, was overshadowed by the technological means needed to create mass housing. This inscription reflects the historic depth of earth architecture. Nearly 5,000 years ago, builders here mixed soil and water, formed them into bricks, and dried them in the sun. This earliest and most widely used system of earth building evolved in sophistication and has created monuments which attest to the magnificence of what could be done with earth. With the onset of the Industrial Revolution and the sudden appearance of towering giants of steel and glass, these treasures of earth architecture were filed away as relics from the past. Unlike the West, cities in the developing world had modernization thrust upon them without the benefit of long-term planning. Infatuated with the power and versatility of Western building technology, indigenous people began to look down upon their vernacular traditions as being symbols of their underdevelopment.
لا هو صراحة يعني الحرارة بتاعته بتبقى كويسة بس بقى نعمل ايه قدر الزلزال جه برضه يطبق ده على ده.
هر کس که گفتم که خونه ای که خشتگلی نداشته اومده ساخته بهتر خونه ساخته توش نشسته. هر کس نداره دوست داره تو اون خونه زندگی بکنه.
In the developing world, where access to modern construction technology was limited to a privileged few, the material earth became associated with poverty, further exasperating the inferiority complex those people felt towards their indigenous homes. In an attempt to address this regressive attitude and counter the onslaught of Western industrial methods, Egyptian architect and author Hassan Fatih first proposed reintroducing earth construction as an alternative.
It is for the potential in this material to solve the problem of housing for the millions who are the handicapped. I call them the economically untouchables.
In the late 1940s, Hassan Fatih had the opportunity to realize his bold vision in the building of a new settlement to house 7,000 people in Ghana, Upper Egypt. Although the project never fully succeeded, its humble but elegant domes and vaults reignited interest in earth building by architects throughout the world. In the United States, the Dar al-Islam Foundation invited Fatih to design the Religious Community Center. Here, near Santa Fe, New Mexico, these structures stand as a reminder of the aesthetic potential of earth architecture.
When I build a house for a peasant, I build it for myself, the peasant. When I build a house for a prince, like you, I build it for myself, the prince.
Up to year 1974, I was practicing both in Iran and United States, and my specialty was skyscraper, high-rise buildings.
Another architect to travel on the earthen path is Nader Khalili.
I closed both my offices in Iran and America, and bought a motorcycle, went to the villages for 5 years to learn with the earth architecture that existed for thousands of years, like the Brujardi house in Kashan, which is one of the ultimate examples of what could be created with mud and the highest sophistication in architecture that exists today and still is in use.
In these desert regions, where lumber and other natural resources are scarce, Khalili became intrigued by the ingenious techniques employed to erect structures entirely of earth. Like an inverted eggshell, domes and vaults are compression structures which work in harmony with gravity. This allows the earthen blocks to create roofs without beams, thus eliminating the need for steel and lumber. These strategically positioned earthen towers are wind catchers, which either funnel cool air into the building or exhaust hot air depending on the direction of the wind. Underground cisterns, with the thermal insulation of earthen material and the natural refrigeration of the wind catchers, store the cold winter rain, and in centuries past quenched the thirst of desert caravans in the summer heat. Khalili wondered if these age-old techniques could be revitalized to address the shelter crisis and concerns for the depletion of our natural resources.
In Iran and many places of the world, I saw that unfortunately the most beautiful earth architecture had been inundated, had been destroyed by modern type of architecture that was steel and concrete, and so inappropriate for the environment and the place, because people all were impressed that these were what the West has created, and they saw that as symbol of progress. Therefore, they blindly imitated everything.
Structures made with steel and concrete are generally unsuited for harsh desert areas because they create oven-like interiors in the summer days and provide too little insulation against cool nights. To make them viable requires machinery that taxes environmental and financial resources. Earth homes, however thermally efficient, were plagued by other weaknesses.
Main problem with the earth architecture was erosion in rain and snow, and of course earthquakes. And I was inspired for years of the possibilities of firing these buildings to become a monolithic structures. And I went after these dreams until I came across a kiln, a brick kiln, a ceramic kiln that was standing there for centuries because the kiln was fired and glazed and it could resist. Therefore, the solution, the answer to what I was searching for years was already at the turn of a road in a village.
After experimenting with the firing of small existing homes, Khalili worked with master masons to construct a 10-room school entirely of adobe bricks. Employing the available local technology, they used gravity-fed oil burners to fire the school for several days. This fired ceramic school has been in use for more than a decade. The quest for the validation of earth as a viable building material can also be found in France. The 18th century pioneering architect François Cointreau used the technology of his time to refine a system of building with earth called pisé, today known as rammed earth. Mixtures of earth were pounded under pressure between wooden forms. The forms were removed, creating thick-walled structures. Driven by the enlightened goal of the French Revolution, Cointreau envisioned rammed earth as a solution to the problems of building for the masses. However, the very accessibility and simplicity of earth building posed a threat to the established practices and interests of his contemporaries.
Et qui ne pourra jamais croire que cette maison que je leur procurais devait servir de modèle à 500 000 habitants qui occupaient ce vaste pays? Qui pourra aussi croire que lorsque j'eus bâti ce modèle, je fus obligé de me sauver d'Amiens, qu'après ma fuite, les maîtres ouvriers et marchands s'empressèrent de jeter à bas mon modèle?
200 years later, in the countryside near Grenoble, stands Domaine de la Terre, the embodiment of Cointreau's ideals. These 72 multi-story townhouses are a social housing project sponsored by the French government and envisioned by Jean Détier, whose exhibit Down to Earth at the high-tech Pompidou Center in 1982 attracted mass audiences to earth architecture.
When I was working as an architect in Morocco during 6 years, I remember that trying to convince my Minister of Construction to build in earth in Morocco social housing or any kind of other social project, he always finished the discussion by mentioning that if it was so interesting, there should be some example in Europe. When I was in the process of preparing the exhibition, then I remembered that and I said, we must build something here. It's not enough to say and to show that Earth has a future. We must demonstrate it.
The Domaine de la Terre complex was designed and realized through the efforts of CRATER, the French Center for Research and Study of Earth Building at the School of Architecture in Grenoble.
We became aware that without the industry, earthen architecture would go nowhere, except on village level, etc. And this is quite new as well in history.
This temperate region, subject to rain and snow, provides a working laboratory for experiments with improved earth technologies in order to overcome the drawbacks of climate and soil limitations.
These kinds of compressed earth blocks that are quite familiar to many people, that is unfired. That means that those bricks that are produced by industrial means, extruded, don't have to be fired anymore, neither dried. And they have exactly the same characteristics as a fire brick. Means 50% less energy in this for exactly the same product.
In this house, a sheet of glass in front of the earthen walls creates an insulating air trap. The sun's heat is absorbed into the walls by day and is re-radiated into the house by night.
What we can say here is that this architecture, its aesthetic, is quite the common one of the local architecture we can find in other neighborhoods. This is very important, in fact, because to make a demonstration that the architecture made with earth can be very common architecture and not a specialized architecture.
Ah, mais moi je préfère avoir une maison agréable avec un volume et un petit peu de poussière sur la table, moi ça m'empêche pas de vivre. Hein? Plutôt que de vivre dans un appartement traditionnel, clean, mais sans aucun cachet, sans aucune âme. Un genre de maison, ça vit, c'est une chaleur, ça. Moi j'espère qu'une chose, c'est qu'ils me la vendront un jour.
We have buildings standing up today that are 200, 300, 400, 500 years old and that are still in perfect condition. The only thing is that we forgot a bit how to do it. Now, science is there today. We know again how to do it, so we can do it.
Whereas the Groupe Cratère is inspired by a rich tradition of earth architecture in France, European settlers in North America relied upon resources like timber to fashion homes in familiar forms, laying the foundation for a rapidly developing industrial society.
These are the 36 men who built this house. Another day, another 40 houses.
And yet, tucked away in scattered corners of this nation, there are various examples of earth architecture that hark back to the earliest indigenous inhabitants of this continent.
Nói tới là nó phải buôn bài thư nào mà có mà còn mà nó vô á mình vô mà giống là có là cái quỷ nên thầm mà ý anh còn mà giống thấy nói thư nói là nó phải buôn bài đấy thư nói là có hí là nó cái nào lắm mà giống là còn là quỷ nên là cái là thư ý họ bây giờ nó hi bỏ lên này là cái chú ấy mà em.
Dating back nearly 800 years, the pueblo of Taos, New Mexico is one of the oldest continuously inhabited dwellings in North America. Constructed by the Tao Indians, these traditional structures are built of adobe blocks.
For the adobe houses to live on, we have to take care of them like you would take care of a child. You clothe a child, we plaster the adobe houses so they can stand up. Now we're going to go inside and I'm going to let you see the house that we had renovated. Here, when you live in a house, it's almost like part of you because you live in it and it lives with you. If you keep the house warm, it'll keep you warm. And it's almost like if you die, the house will also die with you. When you build a house, you build a house with what you're actually standing on. Once upon a time, maybe there might have been a house there also, but the recycling of adobe material is almost like building what had been there once upon a time.
And here we find another authority, Mr. Norman Denny, Vice President for Materials of Levitt & Sons. Mr. Denny, we see that you're using asbestos cement siding on your homes. Can you tell us why?
Yes. These sidewalls help us create distinctive and attractive homes. It has a long life and a low cost of maintenance. And first, last, and always, our customers like them. And what they like, we like.
Thank you, Mr. Denny.
In post-World War II America, the preference for single-family homes mushroomed. Rising to the challenge of this demand, the forces of industry and technology were harnessed, opening markets for the entrepreneurs who promoted newly synthesized building materials and the tradesmen who built with them. Ancillary enterprises such as insurance and mortgage banking became the backbone of the booming economy, creating a standard of living envied the world over.
This money, the savings of all these people, when put to work in this way, well, it benefits everybody. The butcher, the baker, the candlestick maker.
In the United States, a culture of consumerism and a misperception about the viability of earth hinder its potential acceptance as an alternative building material.
There are many economic interests who see it favorable for their position not to have very much earth building occurring in the United States. And that's the lumber industry, the cement industry, in a major way, the cement industry. This is where their influence has affected the codes, because these codes, the earth walls are engineered as cement walls, courtesy of the cement industry.
One of the problems about adobe is that it's not considered a, quote, legitimate building material. In other words, by Western industrial standards, it's supposed to be soft. It's supposed to be so soft that it's dangerous to live in it.
This machine makes a compression test of adobe blocks. This represents the types of forces that are placed upon adobe blocks in an actual building. And these would be the forces of the roof weights, of the weights that are induced by earthquake and wind on the building. And these kind of tests are the kinds of things that we will need so that we can feel much more confident in using these materials.
Now, another test that's used is to take an adobe brick and subject it to tremendous pressure. And then if you subject it to hundreds of pounds per square inch of pressure, well, of course, it crumbles. No brick, no adobe brick in a standing wall is ever subject to that kind of pressure. So adobe is a system. It's not just a matter of individual bricks that you can browbeat one way or another.
The field of adobes that I'm standing in has been semi-stabilized with emulsified asphalt, 3 to 5% by weight. Now with these modern stabilization methods with asphalt, you can build with it anywhere.
Now another test that's used is to take an adobe brick and submerge it in a pail of water, and lo and behold, it dissolves. Well, this is supposed to prove that adobe is vulnerable to rain. Well, it's kind of ridiculous because rain only attacks one side of an adobe brick at any given time. An adobe brick, by the way, which is covered almost always with adobe plaster so that the water doesn't reach the brick at all.
I've stressed the importance of the need for California to reform its codes toward adobe and rammed earth. The reason being that most all states in the Union adopt their codes from those put together by the state of California, and it's adopted by the Uniform Building Code officials.
The provisions of this code are not intended to prevent the use of any material or method of construction not specifically prescribed by this code. Approval of a request for use of an alternate material, assembly of materials, equipment, method of construction, method of installation, or means of protection made pursuant to these provisions shall be limited to the particular case covered by request and shall not be construed as establishing any precedent for any future request.
Nowhere in the United States are the building codes and regulations more stringent than in California. Near San Francisco, in Napa Valley, David Easton has been working to advance the state of earth building and to establish the safe standards by which this material can be judged on its own merits.
I somehow felt, when I began to explore construction materials, that earth had a potential. Earth had a place in modern construction, and what I was able to add to The technology was some improved engineering, some Yankee ingenuity to take a successful material and upgrade it.
David Easton works with the rammed earth method of construction, updating Quantero's techniques. Modern equipment speeds the process. The soil is mixed on site and then poured into the wooden forms. Pneumatic tampers compact the earth. The forms are then removed, revealing a 2-foot thick wall. The wall is complete. It needs neither exterior shingles nor interior finishes. Skillful layering of the soil creates attractive, ready-to-use interiors. Rammed earth requires more complex technology than adobe, but can raise massive walls in a shorter period of time.
When the first rammed earth project was submitted to us for approval, we were obviously confronted with a product and a material that wasn't code recognized. So what we were faced with is, can we use it? And if we can, how do we use it and what limitations would we place on it? Basically, we looked at it as a low-grade concrete product.
In fact, earth reacts differently than a low-strength concrete. It's more of a plastic material. Now, it's a very low-strength material, but with thick walls and low-rise buildings, you can design a safe, unreinforced clay masonry building. Unfortunately, with Ted Morrison, this isn't a valid approach.
I don't think that this particular department is an enemy of innovation. Basically, we've approved rammed earth. It would have been very easy for us to take the position that since the concept is not code approved, go to Whittier, go to the headquarters of the International Conference of Building Officials, submit your information, take 5 years, get your approvals, and then come back and talk to us.
ICBO certification, though, is a procedure that it has to fit in to the larger scaled construction industries. Big companies that spend thousands, hundreds of thousands of dollars on research and development to bring a new material to the market, a material that these people are going to make money on. The problem with earth building is that there is no big profit. It's a hard sell, is what you might say. Madison Avenue might call earth a hard sell.
The affluent community of Napa has provided the testing ground for David Easton's work. Here, facing the challenges of working with an unrecognized technology, he has managed to build numerous rammed earth homes for a growing group of clients.
I met David Easton out of Napa and visited him in a rammed earth home. And there was such an aura and such a calm and a peacefulness about the rammed earth house that I was in on a cold day, which was very warm inside, only having a fire built in the fireplace. The design of the house is one great large open space because I like to combine the living, the dining, and the kitchen all in one great room. That's the way we live in Northern California, particularly in the wine country, so it works very well. And the guest bedroom, again, gives a wonderful feeling of an old world charm with the walls. The concrete perimeter beam is completely exposed, and the decorating within the room, again, is more contemporary.
The conflict here is that earth is being taken, at least here in Northern California, into the realm of the expensive material. Not because earth isn't a humble material, but because the architecture that's tied into an opulent lifestyle is expensive to build. And we're utilizing the revenue, the income from these houses to sponsor our research, our development, so that we really can reintroduce earth as every man's material.
In 1993, Pacific Gas and Electric, a California power utility, sponsored the construction of a prototype, affordable rammed earth house designed and built by David Easton. This showcase home is being monitored to assess its thermal efficiency with widespread potential for use in California's hot Central Valley.
When I look at this reddish-brown building, I really see a green building here because green is the color for the environment and green is our resource plan. And this building, to me, represents what's good about America and what's good about the environment.
The utility company hopes that building such tract homes on a mass basis will avoid the necessity of constructing costly new power plants solely to meet peak summer air conditioning loads.
We understand that if we're going to live on this planet successfully, that it's got to be a long-term strategy. And long-term sustainability in housing is a key issue.
400 miles south of the lush Napa Valley, in the high desert town of Hesperia, California, a different type of earth building is taking place.
The only way that you can convince the third world that what they have is valuable and great is to do it in the West, especially in the United States.
Architect Nadir Khalili, who left Iran after his experiments with firing buildings, has picked this site of harsh summers, winter floods, and seismic dangers as the site for his California Institute of Earth Architecture.
The only way these arches stand is because of its balance. Balance with gravity, they'll stand with sand. And if they can build with sand, they can build with mortar very easily.
Just right, notice how we both
Gives in. If you don't have this buttress against it, once you pull out the form, it goes. Because you need to have an arch with a buttress right next to each other. Go to the side, to this. Okay, give yourself a hand. Ah, you have a hand, very good.
Khalili, who strongly advocates using the arch and dome forms, so well suited to earthen structures, is experimenting with the base isolation method of dome construction in order to make these buildings earthquake resistant. With no conventional foundation, the dome sits on a bed of sand, buttressed by the sides of a 3-foot deep hole. If an earthquake strikes, the dome shakes on its bed of sand like an upside-down bowl. In this highly seismic region, the real test came sooner than expected.
The earthquake which hit was 7.4 magnitude in Richter scale, less than 50 miles from here. And the inspections after that showed that there was not a single failure in the structures because of this uniform movement of the structure within the sand, really on the base isolation.
To meet the challenge of building affordable housing, Khalili and his associates devised a system of using sandbags as building blocks. Stacked like bricks, a ring of barbed wire is then placed between the bags, serving as a tension binder for the structure. Finally, a coat of mud plaster is added to protect the dome.
The basic philosophy and idea here is, one, how to turn the military use of sandbags and barbed wire into housing for the people in the world. And second, how to use the lowest cost and the simplest way of building with any material that exists at the site, any place.
In order to meet the United Nations minimum requirements for habitation of 500 square feet per family, the sandbag concept has been expanded to a 3-room vaulted house.
Pioneers came to this country, as I said before, with the hammer and saw and some nails and built themselves houses. Now, everything that you want in a house, you have to go to the banks and the insurance company and loans and so on, because people have left all these to the hand of organizations. They have become more or less homeless because they don't know how to build their own homes.
To make these experiments into a viable reality, testing approved by the International Conference of Building Officials was carried out. The dome was loaded eccentrically with sandbags to simulate building loads, wind forces, and the shock from earthquakes. Unacceptable deflections measured against the plumb lines would indicate the potential failure of the structure.
The sandbags approximate 80 pounds per square foot loading, which is greater than the Uniform Building Code requires for this type of a structure. So we're loading it and testing it about 200% greater than expected.
For 3 days, Khalili and his associates anxiously awaited the result of the tests.
Natter? It's okay, there's no deflections.
The acceptance of these prototype structures by the California Code administrators and their potential implementation in the West will perhaps inspire a renewal of earth building in the developing world.
This will become your living room. This is your dining room and kitchen. And here will be your solar oven. So the kitchen here, you push out your food into the solar oven. And then here is your wind catcher that cools from a tower. The cooling comes here and the natural cooling system. And you go out here and you have a bathroom here and a bedroom.
It's new and different, and that kind of makes us a little nervous at times, but in all honesty, it looks like it's very solid construction. We've got, working with the Building Officials Conference, it looks like they have accepted the type of testing that we're doing here. This obviously would open up hundreds of opportunities around the world for low-cost, affordable, energy-efficient housing.
From Quantaro to David Easton, from Hassan Fatih to Nadir Khalili, visionary pioneers in many parts of the world have struggled to revive and improve the rich tradition of earth architecture. The time has come to re-evaluate the prejudices towards this ageless material, to relearn the wisdom of the ancients and see it not as the mere dirt beneath our feet, but the substance from which our future may be shaped. Perhaps then we shall truly be at home with Mother Earth.